Okay, so you've probably heard the term Kubernetes, or K8s, thrown around. And yeah, it sounds complex, maybe a little intimidating, but it's actually one of the most important technologies powering the apps you use every single day. So let's just dive in and figure out what this thing actually is and why it's such a massive deal.
To really get Kubernetes, we first have to understand the problem it was built to solve. And honestly, it's a problem that we've all created.
I mean, think about it. When was the last time you were okay with your favorite app just being down for maintenance? We expect everything, our banking, our social media, our games, to just work all the time. For modern apps, this isn't a nice-to-have feature anymore, it's the absolute baseline.
That demand for constant uptime, plus the need for new features to roll out like yesterday, creates this huge technical challenge, right? How do you update an application without taking it offline? How do you handle a sudden flood of users when something goes viral? That's the real question.
Well, the answer really lies in this fundamental shift in how we build software. We had to move away from the old way of doing things. So in the past, applications were often built as a single giant block of code. We call that a monolith. And if you wanted to update one tiny part of it, you had to redeploy the whole thing. It was slow, it was risky. The solution? Break it apart into dozens or even hundreds of tiny independent services called microservices. This was a game changer. It meant different teams could work on their own little piece of the app and push updates way faster without tripping over each other.
And this is great for speed and flexibility, for sure. One team can update the shopping cart while another works on the user profile. But you've just traded one big problem for hundreds of little ones. How do you deploy, connect, and monitor all these tiny pieces so they act like one coherent application? It's basically organized chaos.
And this, right here, is where Kubernetes enters the stage. It's the system designed specifically to be the conductor of this microservice orchestra.
You know, this quote from the official documentation really just nails it. At its heart, Kubernetes is all about running those containerized applications, those little microservices we were just talking about. It automates the whole process of getting them out there, making sure they stay running, and giving them the resources they need to do their job. The technical term for what Kubernetes does is container orchestration. But honestly, the best way to think about it is like an orchestra conductor. The conductor doesn't play the violin or the cello, right? But they make sure every musician starts on time, plays in key, and works together to create something beautiful. Kubernetes does exactly that, but for software containers.
So how does this conductor actually work? Let's break down the core components, and we'll start with the hardware itself.
Okay, so at the base layer, you have these worker machines called nodes. Could be a virtual machine, could be a physical server. A group of these nodes forms a cluster. Now, what's so powerful here is that as a developer, you completely stop thinking about individual machines. You don't care if your app is on server A or server B. You just talk to the cluster as this one giant unified computer, and you say, hey, run my app. Kubernetes figures out the rest.
Okay, so that's the hardware layer. But developers, they rarely interact with it directly. Instead, they use a set of really powerful software ideas or abstractions that Kubernetes gives them. Let's check those out. The most fundamental unit, the smallest little atom in the Kubernetes universe, is the pod. A pod is basically just a wrapper around one or more of our application containers. It's the smallest, most basic thing that Kubernetes can deploy and manage.
But you almost never manage pods one by one. I mean, that would be crazy. That's where deployment comes in. And this introduces a really critical shift in thinking. You don't tell Kubernetes how to do something, you simply declare the state you want. You just say, hey, I need 3 copies of this application running at all times, and the deployment's job is to work 24/7 to make that a reality, automatically replacing any pods that crash.
Awesome. So we have pods, and they're being managed by a deployment. But pods can come and go. They get created and destroyed all the time, and they get new network addresses. So how does anything talk to them consistently? Well, that's the job of a service. It gives you a single, stable network address that automatically routes traffic to the correct set of living pods. It's kind of like a smart internal traffic cop. Now, with those building blocks in place, we can unlock the real superpowers of Kubernetes, the things that make it so incredibly useful for running modern applications. One of the biggest superpowers is automatic scaling. Imagine a huge traffic spike hits your app. Instead of it crashing, Kubernetes can see what's happening and automatically add more pods to handle the load. As you see here, a metric server watches the usage, an autoscaler does the math, and it tells the deployment to spin up more pods. And just as important, when traffic dies down, it scales everything back down so you're not wasting money.
All of this happens without a human lifting a finger.
Scaling is one thing, but with hundreds of services, the network of communication between them can become a tangled nightmare. How do you handle stuff like secure communication, retries if something fails, and just general monitoring between all these moving parts?
The modern solution to this tangled mess is often something called a service mesh. Now just look at this slide for a second. On the left, you've got the before state. All that complex networking logic for things like security and metrics is baked into the application code itself. It's a mess. Now look at the after picture on the right. A service mesh basically rips all of that logic out of the application and moves it into its own dedicated layer. This layer handles all of the communication between the services automatically. It means developers can just focus on building features, knowing that secure and reliable communication is just handled.
So we've covered a lot of ground here, from monoliths and microservices to pods and service meshes. Let's pull it all together and talk about why this technology has fundamentally changed the game for building and running software.
So when you put it all together, what has Kubernetes actually given us? Well, it's a way to tame the crazy complexity of modern apps. It automates all the boring, error-prone work of scaling things and keeping them healthy. It creates this abstraction layer so developers don't have to worry about the underlying servers. And maybe most importantly, it frees up developers to do what they do best: build cool new features for you and me.
And that really brings us to the final thought, doesn't it? By abstracting away all the complicated plumbing and infrastructure, Kubernetes has created a foundation for the next wave of innovation. It really makes you wonder, with all that creative energy unlocked, what are we going to build next?